Hi there. Here are some definite integral problems. If you are practicing these in preparation for your test, I would recommend pausing the video so that you can attempt the problem on your own and then restarting it when you're ready. That will allow you to either watch the video if you need some sort of explanation, or if you would like to just fast forward to where the answer is, you would be able to double check what your answer was. Okay, so these problems will say something about evaluating the definite integral or something along those lines. And so our first one here is going to be the definite integral from 2 to 5 of x squared minus 2 dx. Okay, this one is probably about as basic as it gets because this is straight power rule. There's not even any manipulation involved. This just gives us a chance to see kind of what fundamental theorem of calculus would be. So I'm going to go ahead and add 1 to the exponent, divide by the new exponent. I'll then plug in the upper. 5 cubed is 125 over 3 minus 2 times 5 is 10. Minus, plug in your lower, you get 8 cubed minus 4. Okay, well, 10, to find a common denominator, would be 30 over 3. And 4 to find a common denominator would be 12 over 3. 125 minus 30 is 95. And 8 minus 12 is negative 4. So this would be 99 over 3, or 33. Okay, let's do another. Moving definitely into or out of kind of basic power rule. Let's go ahead and do, let's do negative 2 to 4 of x squared times the quantity of x cubed plus 8 all squared dx. Okay, now I'm going to utilize this one as a calculator review. Just make sure we're comfortable plugging this into our calculator. Okay, so if this were a calculator problem, I wouldn't need to do any work, although just for the record, if this was a non-calculator problem for some reason, my u would be x cubed plus 8, my du would be x squared, or this wouldn't be the end of the world to FOIL out and to then distribute the x squared. But I personally would probably do u to u. Okay, so to plug it into our 84s, we're going to go ahead and hit math, and then go down here to number 9, or you could just hit 9 if you don't want to scroll down. When you hit enter, you then get your definite integral setup. So we'd go negative 2 to 4 of x squared times the quantity of x cubed plus 8 all squared dx. And when you hit enter, it'll give you your definite integral, which is 41,472. So I am glad we did not solve that one without our calculator. Okay, let's go ahead and do another one that might be a non-calculator one. What if we did the integral from, let's do a trig, 0 to 3 pi over 2 of cosine 2x over 3 dx. Okay, this one is a u to u problem, and it's one that's easy to miss because it's very tempting to say, oh, I know the integral of cosine. The integral of cosine, or the antiderivative of cosine, is sine. The problem with that is the antiderivative of cosine singular variable is sine singular variable. This is not a singular variable. I have numbers in there with my x, okay, meaning I need to do a u to u substitution on that component there, that 2x over 3. Okay, my derivative then would be 2/3. And I don't have a 2/3 in the equation, but that's okay because I can divide that 2/3 over to the other side. And remember, dividing by a fraction is the same thing as multiplying by its reciprocal. Okay, so now we have dx is going to be called 3/2 du. My 2/3 x is going to be called u. And now I have cosine of a singular variable, so I'll be able to take the antiderivative. Okay, because we switched to u to u, we're going to go ahead and switch our bounds, because these are x bounds. To turn this 0 into a u, I'm going to go ahead and plug it into my u here. So 2 times 0 divided by 3 is still 0. Okay, but the 3 pi over 2 when I plug that in, and I'm going to go ahead and show that, I'll show it down here. Okay, 2 times 3 pi over 2 divided by 3, plugging it in right here. The 2's are going to cancel, leaving me with 3 pi over 3. And then the 3's are going to cancel, leaving me with pi. Okay, so now I can go ahead and take the antiderivative. Like we mentioned at the beginning, the antiderivative of cosine is sine. Then I'm going to go ahead and take my upper, plug it in. Sine of pi. When you think of where pi is over here at -1, 0, cosine sine. And so sine of pi is 0. Minus, plug in your lower, sine of 0, 0's out here. Cosine sine, sine of 0 is also 0. Well, 3 halves times 0 minus 3 halves times 0 is 0. Okay. And let's go ahead and do an absolute value then. Okay. We have the integral, excuse me, sorry. We have the integral from 0 to 3 of the absolute value of x squared minus 4 dx. Okay. So, absolute values. The first step of the absolute values, I first of all don't know how to take the integral of an absolute value, so I need to split this integral wherever there's a cusp so that I can get rid of the absolute values by forcing the function in each of those breaks to be positive, because absolute values have to be positive. So the first step here is going to be to say, okay, well, where are my cusps? Where am I going to break it? Okay, well, my cusps are wherever the absolute value or the inside of the absolute value equals 0. Okay, which this factors to x minus 2 times x plus 2. And so my cusps are at 2 and -2. And so I'm going to cut my interval up at both 2 and -2. However, -2 isn't on this interval, so I'm not going to do a cut there. I'm only going to do a cut at 2. I'm going to go from 0 to my first cut, which is 2, and then from 2 the rest of the way across my interval to 3. So now we need to figure out which one is or where my positive legs are, where my negative legs are, because we have to take all those negative legs and we have to force them to be positive by changing their sign. Well, to figure out whether a leg is negative or positive, I'm going to test a number on this interval and plug it into my function, my x squared minus 4. Well, when I take, for example, 0 and plug it into my x squared minus 4, I get 0 minus 4, which is -4. An absolute value can't be negative. And so this x squared minus 4, which was -4, I now need to change that sign to be negative x squared plus 4. Because now when I plug in 0, I get positive 4, which is what the absolute value would have done. It would have forced it to be positive. Testing a number on 2 to 3, when I plug in, for example, 3, I get 9 minus 4, which is positive 5. For that 3, the positive 5, the absolute value bars aren't doing anything, and so I can go ahead and just drop them. I'm going to leave this function, oops, that should be negative. I'm going to leave this function as it is because this was already positive, so I don't need to change it to be positive. It's already positive. Okay, so once you've done that, now we're on to the antiderivative, which is we're going to go ahead and add 1 to this exponent and divide by the new exponent. And same thing for the other one. We're going to add 1 to the exponent and divide by the new exponent. We're going to plug in our upper. We get -8 thirds plus 8. Minus, plug in our lower. Which It's going to be 0 plus 0. And then on the other one, plug in our upper. 27 over 3 is 9. Minus, plug in our lower. 8/3 minus 8. Okay? So this is obviously 0, so it's going away. Negative 8/3 plus 8. 8 is going to be 24/3, so I can find a common denominator. Over here we have 9 minus 12, which is negative 3. And over here 8/3, and then again 24/3. Well, negative 8/3 plus 24/3 is 16/3. We have our negative 3 minus, and then 8/3 minus 24/3 is negative 16/3. 16/3 plus 16/3 is 32/3, and this 3 is 9/3, so I have a common denominator. And 32 minus 9 is 23. And there's your definite integral.